Take a break, Adamu. You are listening to Brothers of the Serpent podcast.
And welcome back, ladies and gentlemen, boys and girls, angels and demons, monsters and serpents, to Brothers of the Serpent podcast, coming to you not live from the 10 by 10 by 10 tangent cube of science, nestled amongst the dusty bones of an ancient seabed high atop the Edwards Plateau. And we have a very awesome show for you tonight on this Emergency Backup Podcast Day Wednesday. That's right. But first, as always, we need to introduce our good friend and longhead, Mr. Brett England, from deep beneath his secret space station in secret outer space, the Watcher. How are you doing, buddy? What's going on?
Very excited for tonight's show, man.
Hell yeah.
We're going to talk about effing rocks, and it's going to be effing awesome.
That's right. That's right. So we have a special guest with us tonight, Sheldon from the C Word podcast.
Hey guys, how's it going?
Yeah, what's up, man? So he is an actual geologist. He is an actual scientist. We talk about geology on this podcast. Like, I would say that aside from ancient pyramids, geology is probably the second most popular topic on this podcast, and we have a guy on here now who can actually tell us real stuff about actual geology. When most of it,
I like just thinking that you guys, the amount of research that you guys have done, you probably know more than most people, like most geologists. So like, don't get your hopes up. Like, you guys probably have a good grasp on this. I'm just saying.
Well, I've heard some of what you said on the C Word, and I'm definitely interested in your views on some of these topics. And I know you got excited about the Younger Dryas, so we're definitely going to talk about that because we have really looked a lot into the Younger Dryas event. So,
oh, yeah.
Yeah. But first, before we get into all the geology, we have space weather news. From spaceweather.com, a new sunspot. The sun is not blank anymore. New sunspot AR2734 has emerged in the sun's northern hemisphere, breaking a string of 33 spotless days. This sunspot's magnetic field is a bit unusual, raising a question. Does it come from the next solar cycle? Probably not. The sunspot's relatively low latitude identifies it as a more likely member of old solar cycle 24. That's interesting. And a shallow hole in the sun's atmosphere for the next few days, Earth will feel the effects of a minor solar wind stream. The gaseous material is flowing from this irregular hole in the sun's atmosphere. This is a coronal hole, a place where magnetic fields have peeled back, allowing solar wind to escape. In recent days, several small coronal holes have merged to form this sprawling structure. It is relatively shallow, and the wind emerging from it may be weak and irregular. Solar wind speeds are likely to be the greatest on March 8th, when the body of the gaseous stream intersects with Earth's orbit. Arctic skywatchers should be alert for auroras later this week.
Ah, those lucky dogs.
From spaceweather.com, yeah. So that's our space weather. And then I have a couple of listener emails, which I need to get to. One from, of course, the Grand Watcher, who always sends us great emails. So this one was, of course, in response to episode 87. So he says, number one, was it Arthur C. Clarke that wrote the short story about our space travelers landing on a once occupied planet and finding records left behind about what a beautiful planet, happy families, and peaceful societies that existed there? The surprise ending was when they realized that the supernova that ended life on this beautiful planet was the bright star that led the wise men to Bethlehem. This is why the news about our CD distribution kind of scares me.
You brought that story up?
Yes, I did. Yeah, that was called...
something Light of Days?
Yeah, well, not Light of the Days. It was a short story called... I can't remember the star or something like that. But they basically traveled out there, and the whole thing was done from the perspective of a priest.
Yeah.
And he was writing in his journals, like, how can I even reconcile this with what I think about God? He wiped out this entire civilization to give us a sign. It was a great story. Arthur C. Clarke got invited to speak at the Vatican because of it.
Yeah, that's cool.
Oh, cool.
Yeah. So number two, he says, this is for you, Kyle. You do have the best theme song and break music of any of the podcasts or YouTube shows and KGRA shows that I monitor, which are 8. See, the Grand Watcher watches 8 shows.
Wow.
Thank you, Grand Watcher.
Yeah.
That is wild.
3, what if the whale had always wanted a spectacular death and so swam shoreward as fast as it could, then jumped off the end of a hellacious wave? You know, like he was had a spurned love problem or something.
That could totally happen.
in reference to a story that Kyle read about a whale that was found like 50 yards or 50 feet away from the shore of a river in the Amazon.
Yeah.
And they said it was what do they call it? A powerful tide launched the whale into the jungle.
Yeah. Better watch out, surfers. There's a whale launching tide coming in tonight.
4, magnetic stimulation of the amygdala has a lot of hard medical evidence of curing PTSD and otherwise unresponsive depression in as little as 6 weeks. So that's interesting. Magnetic stimulation. So we were talking about various medical administered drugs that can cure various things, and he said PTSD can be cured by magnetic stimulation.
Magnets.
Yeah,
That's cool. Yeah, that's one way to do neuroplasticity, I suppose, because it's electrical.
exactly. Yeah. 5, I think ancient aliens and previously very advanced Earth societies are the same thing in a way. When the calamities were imminent, our previous societies headed for various other planets to survive. After the planet recovered, they returned to help the newly developing humanoids to hasten their growth as societies. That sort of thing is still ongoing today. So he's basically saying that ancient aliens and ancient civilizations are, or could be the same. Mm-hmm. That the ancient aliens are previous humanoid civilizations from Earth that left and are returning.
Yeah. That's a cool idea,
Yeah.
too.
Okay.
Yeah. So that's from the Grand Watcher. He has a 6, but it's actually a tech support problem, so I won't read that on the show. We'll let the Watcher deal with that. Now we got one from the Stash. The Snake Father, who was on the show on episode 84.
I don't remember. I didn't remember what show this was.
He says, Snake Sons, in regards to your mention of the SpaceX launch of data on CDs, here's a reminder that we have done this before with what most today would call primitive technology. In 1972 and 73, NASA launched Pioneer 10 and 11 with data plaques attached. And then he has from Wikipedia, the Pioneer plaques are a pair of gold anodized aluminum plaques that were placed on board the 1972 Pioneer 10 and 1973 Pioneer 11 spacecraft, featuring a pictorial message in case either Pioneer 10 or 11 is intercepted by extraterrestrial life. The plaques show the nude figures of a human male and female along with several symbols that are designed to provide information about the origin of the spacecraft. In other words,
and how to find us.
Right, how to find Earth. Great. The Pioneer 10 and 11 spacecraft were the first human-built objects to achieve escape velocity from the solar system. The plaques were attached to the spacecraft's antenna support struts in a position that would shield them from erosion by interstellar dust. And then he also says that both Voyager spacecrafts carry a greeting to any form of life that should be encountered. The message is carried by a phonograph record, a 12-inch gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. The contents of the record were selected for NASA by a committee chaired by Carl Sagan of Cornell University. Dr. Sagan and his associates assembled 115 images and a variety of natural sounds. To this, they added musical selections from different cultures and eras and spoken greetings from Earth people in 55 different languages.
That's cool.
And I think the Stash is asking, did they include the record player?
Yeah.
I mean, how are you going to play it if you don't know? So he says, here's a cool link showing where the Voyagers are now and how far away they are from the sun. Talk about stuff hard to find in the universe, because I was like saying, if you put them in orbit, and you were like, yeah, but that'd be hard to find. Well, Voyagers are just headed out into interstellar space, right? And as far as I know, we haven't received a response from any ETs to our messages. So my question is, are these new CDs launched by SpaceX protected against a coronal mass ejection? Will the data be wiped if that happens?
Good question.
Yeah. Low tech rules the Stash.
The Stash was on episode 84, by the way.
I got it right. Sweet. And I got the star right. Man, I'm on point today, guys.
And as you all know, we are also still analog here in the 10 by 10 by 10 Tangent Cube of Science. We have a 2-inch tape machine running behind us, recording this whole thing. Just kidding.
Lies.
I was gonna say, like, that would have been awesome. I mean, that would have been like nice. That's dedication, right there.
Yeah. We do with the band with $50 Dynasty when we're producing an album. We like to
Use the analog.
if we can afford it.
Nice.
We like to use the analog board, the solid state Logic board to mix down, and we've done a couple of albums on 2-inch tape.
Yeah.
So
Oh, nice.
it's
That's
really
cool.
nice natural magnetic compression.
Yeah.
Yeah.
All right. Did you have news stories that you wanted to do?
I have one news story.
one news story.
It's a dirty news story. So get ready. Ancient poop may have helped solve a 1,000-year mystery about the fall of a long-lost city named Cahokia. Details of the ancient... Oh, I always forget this. This is from thesun.co.uk.
.co.uk.
That's right.
All right.
Details of the ancient U.S. city's collapse has long baffled scientists, but the secret may have been hidden in feces the entire time. Cahokia is a famed city that once existed near St. Louis, Missouri, but had disappeared by the time the USA was colonized by Europeans. By using traces of human poop and environmental data, scientists were able to uncover a climate disaster and then link it to population decline at the city. Experts now believe that a drought was to blame for the collapse of Cahokia, which had been abandoned by 1400 AD. The way of building population reconstructions usually involves archaeological data, which is separate from the data studied by climate scientists, said A.J. White, a lead author on the study from California State University, in the PNAS journal. One involves excavation and survey of archaeological remains, and the other involves lake cores.
Oh, yeah.
We unite these two by looking at both kinds of data from the same lake cores. Researchers were able to detect signatures of human poop in lake core sediments that were collected from the Horseshoe Lake near Cahokia. These signatures are known as fecal stanols. I think I'm pronouncing that right. I don't know. And are simply molecules produced in the human gut during digestion and then eliminated in the feces. As native Cahokians pooped on the land, some of it would have run off into the lake. And the higher the population of Cahokia at a given time, the more stanols would have been evident in the lake sediment. Sediments in lakes accumulate in layers, which allow scientists to capture exact moments of time using collected cores. Deep layers formed earlier, so by digging down, it's possible to analyze soil from further back in time. During the study, it emerged that concentrations of poop traces rose and fall, roughly in line with estimates of Cahokia's population. This effectively proved that it was possible to track population using levels of poop in lake sediment cores.
That's amazing.
I can't believe they're calling the shit poop. I don't know. Anyway, Cahokia scholar Professor Cecil Schroeder of the University of Wisconsin-Madison said that excavations of houses in and around Cahokia show human occupation of the site intensified by around 600 AD. And by 1100 AD, the city, which measured 6 square miles, had reached its peak population of tens of thousands of people. But by 1200, Cahokia's population began to decline, and the site was abandoned by around 1400. Environmental data inside the sediment cores can give clues about why this happened. When we use this fecal stanol method, we can make these comparisons to environmental conditions that hitherto now we haven't really been able to do, said White. Information gathered from the core suggested that summer rain was reduced around the time of Cahokia's population decline. This could have prevented Cahokians from growing maize, their staple crop, forcing them to move elsewhere. This drought could have been the main factor for the collapse of Cahokia as a major U.S. city. When we see correlations with U.S., was not a U.S. city. When we see correlations with climate, some archaeologists don't think climate has anything to do with it. But it's difficult to sustain that argument when the evidence of significant changes in the climate shows people are facing new challenges.
Mm-hmm. So basically, they can tell that the population declined after a climate disaster because everyone was shitting their pants. That's my TLDR of that story.
Yeah, so
That's awesome.
I actually read a couple of different stories on the same subject after I found this one, which was a link in one of the news aggregate sites that I look at. I went looking for other stories and read different ones, and it's almost comical the way they're trying to deal with this climate change problem that's going on with these people that were not burning fossil fuels.
Oh, yeah.
So the climate starts changing, and these ancient people that obviously were not contributing to it because they weren't driving SUVs had to bail. And it was just funny.
Oh, so you had some pretzel dancing, basically?
Yeah, there's lots of pretzel dancing involved in that
you.
story. But I thought that was cool. What do you think about that, Sheldon? You ever study stanols in your cores in the mining industry?
Actually, that's one thing we didn't really look for too much, believe it or not, was shit. But I mean, that's actually pretty cool. It's taken the concept of, various types of incremental dating and things and putting into a different perspective, because they test with lichen Ice core is a big one in geology.
Yeah.
You know, with I think in biology they use like tree rings and things like that, but using things that could be impacted on, so like human contributions, so shit.
Yes.
I mean, with us, it could be like plastic and things like that. You'll see major, I guess, indicators
Yes.
based on the amount of people, or could correlate to the amount of, if it disappears really quickly, it could have been a catastrophe. But
Exactly.
no, it's really neat. It's
Yeah,
really
so-
cool. I would have never thought to look at shit in like sediment.
Yeah.
Who would have thought to look for shit in sediment?
Yeah.
That's like
You never know what kind of shitty correlations you can make with that stuff.
Hey,
we like to make jokes about that kind of, like that's your profession. And so you imagine like that person when
Who
they,
asks to do? Yeah.
when they were a little kid, like, what do you want to do when you grow up, Johnny?
I want to study poop.
exactly.
I mean,
Nailed
I've
it.
heard kids say weirder things, honestly.
Yeah, that's a good point.
All right, so let's go ahead and get into like what do you like? Tell us how you got to where you are. What did you major in? What's your degree, and what do you do? And we'll start from there.
So when I was like young and stuff, I was really into rocks and mainly like volcanoes, that sort of stuff. Typical kid shit when it comes to like geology.
Yeah.
So I just, I don't know, I had always had an interest in earth science. I was really big into weather when I was a kid. I was one of those, like, my friends joke that I was like autistic. I'm like probably, lie on the spectrum somewhere.
Yeah.
But like I used to just watch the Weather Channel all the time.
Wow.
Like I had a CD collection, like Broiler Encyclopedia, I think is what it was called. I just go through like all like the hurricanes, how hurricanes form, tornadoes, all that sort of stuff.
Cool.
And kind of got into geology in the same respect, right? So when I was going through high school, we didn't have any geology courses or anything like that. But when I was in my last year, my physics teacher was like, why don't you check out geology when you're going to university? I was like, oh, yeah, that's the thing you can do. Oh, yeah. I forgot people actually did that because we didn't,
Right.
we didn't get any exposure. So anyways, I just submitted my application for it in high school and then went to school, and it was pretty cool. So I mainly studied mostly what they call, there's two streams really for us. If you stay away from the geophysics side of it, it's like hard rock and soft rock. Hard rock being like mining, soft rock being oil and gas.
Oh, okay.
So soft rock for like sedimentology and things like that.
Right.
So I mostly dealt with hard rock stuff. So mostly like, economic geology, igneous petrology, metamorphic, stuff like that. And I had a few courses on like global change, hydrology, things like that, just as electives. But after I finished my degree, I went working up in Alberta in the oil and gas sector, and then got homesick and moved home. And now I'm working for a mining company out in Newfoundland here, and we're pretty well mining a mineral that's not that common. It's a pretty niche material, so it has like its own specific use cases.
Is it a platinum group metal?
No, it's not. It's an industrial mineral, not even like metallic. Yeah.
Okay.
So it's it's pretty cool. So I get to go and look at do plans for blasting, look at grade control. Get to see basically all sorts of it because it's a smallish company, right? So you get a bit of exposure to everything.
Right.
It's pretty neat.
That is cool.
So you go down in these mines, or are you
Are you in the office or are you down in the mines?
I'm mostly in the office, but it's open pit, so there's no
Okay.
shafts or anything.
Gotcha.
It's nothing extreme.
You're not down in a labyrinth.
You're not going down with the picks and everything. We're not going down with like a canary, and when the canary dies, get the fuck. No, it's just like, the guys are just like in excavators and loaders and stuff.
Yeah.
And there's, that sort of deal.
And you guys are mining in granite, or what is it? I mean, like, what is the main material that you're mining through? Is it hard rock or?
It's actually very similar to talc.
Okay.
So like it's really soft. I mean, there's a fair amount of quartz with it,
Yeah.
but aside from the quartz, it's mostly like really, really soft. Like if you were to get like some of the powder, it feels a lot like baby powder, so like talc.
Okay, yeah. Like a chalky sort of material is that you're talking about?
Yeah, except it's actually fairly silky because of the morphology of the mineral itself is platey. So it's not like round. It's like almost like leaf-like.
Oh, okay.
Individual grains. Yeah.
Oh, wow.
So it glides along your skin and it makes it nice and smooth, right?
Right.
Except it really dries out your skin, so
Yeah, it's very absorbent.
Yeah.
Okay, so
yeah.
So one of the questions we always have is I have tried to. I'm a layman, obviously. I didn't take any geological courses, but in the course of looking at ancient mysteries, and geology often ties in, even though a lot of archaeologists don't want it to tie in because it doesn't agree quite often with what they think is happening. But we've spent a lot of time looking at geology, and of course, there's the whole when you're looking at human origins. The geological information that is available plays a huge part in trying to decide how the hell we got to where we are now and where we came from and what happened to our ancestors, right? Because you look at the geological evidence of the planet around you, and that helps you try to tell the story of the planet, and that, of course, the story of the planet is going to impact anything on the planet, including us. So yeah,
that's true.
Yeah. So how much do you know about methods of dating for geology? Like, how much of that did you study?
Mostly in school, it was referring to how you get the age of certain rocks in the deposits and things like that. So you usually deal with radiometric dating. You look at a lot of like uranium lead dating. So you're basically looking at the difference of, I think it's lead and uranium, various isotopes of lead and uranium in rocks to give you, based on the half-life, how much lead 206 and 207 compared to the amount of uranium as they decay.
Right.
And that was like, you could do various types of radiometric dating on that. So they're all fairly, when we say, one thing I have to have as a disclaimer is with geology, when you say accurate, it's like talking about like hundreds of thousands or millions of years, right?
Right.
It's like another reason archaeologists might not like geology or geological evidence is the huge variance in the time span, right?
Right. So that's one of the things that we've talked about is that, when somebody tries to date something based on the strata that it's in, for instance, well, you're given a window can be millions of years wide, and that doesn't help you when you're trying to figure out who built what city or whatever, right?
Yeah. Oh man. And the best part is you're looking at rocks, which have been here for a lot of the times, hundreds of millions of years.
Yes.
Things move slow in the geological world for the most part.
Right.
An entire civilization can come and go before that formation changed at all.
Right. Yes.
So there could be a bit of conflict there if you want to use that to support any sort of, especially with human history, because it's fairly recent in terms of the age of the Earth.
Right. One of the main geological evidences that is used is like erosion on. So you have somebody that's gone and they've quarried stone to build some structure, right? With stone, and now that stone has a certain erosion on it, and then that can you can't precisely date with erosion either, but that does tell you something about what that stone has had to go through since it was quarried. Like when you have a perfect block, it's new, and then when you've sat it out there for thousands of years and it's undergone various types of erosion, now you can look at it and sort of say, well, this is how long it's been sitting here exposed, right?
Yeah, well, honestly, the rate of erosion, it's going to vary year after year, but you should be able to tell more, I'd say within, 100 centuries, closer to centuries, as opposed to a lot of the radiometric dating for rocks, right?
Yes.
Because it's been exposed for a shorter period of time, although there's a larger change.
Right.
So, yeah.
And I mean, the half-life thing, because I've looked into the radiometric stuff, and one of the reasons the windows are so large is because the half-life is large.
Yeah, exactly.
Right? So you can't your accuracy is based on this particular radioactive isotope that you're looking at and the half-life of it, and that's going to give you your accuracy amount. And
the sheer quantity is like of like these isotopes from the decaying radioactive material. Usually, it's really, really, really small amounts, right?
Yes, that's right.
So it's going to be harder to detect.
Right, that is true. So
I'm wondering, when you're doing this job, are you doing the dating at all in your job, or is that mainly
don't
in
care.
school? Like they don't care how old it is. They're just like, give me the goods.
Yeah.
Right.
Yeah, I mean, well, it's all the work's been done previously from like our a lot of the Geological Association of Canada has a lot of the dating. They like most of the government agencies deal with dating and mapping for a large portion of in Canada, anyways.
Yeah,
we get most of our information from the Geological Society of Canada, Geological Association of Canada.
Yeah, we have the USGS.
And they do most of the the U.S. Geological Society, I believe.
Yeah, U.S. Geological
like
Survey. Yeah,
that's the one.
Right.
Yeah. So most like in the summertime, most of the geologists that are employed with the government here go and map all across Canada, various areas, right? They do things like testing for, any sort of economic significance. They date it. And a lot of that is the information's already there. So, I mean, with regards to us and our mine, we know we don't really pay any heed to the date or doing any dating for that because the work's already been done.
Right. Okay.
And it won't really help us, it won't really help us be more profitable.
Right.
But I find myself also as a layman, like if I'm driving by a quarry, like we have a company called Martin Marietta in our area that they just get aggregates, for building roads and making paths for buildings and whatnot. But their quarries are dotted around the area. And so you'll drive by one and you'll see this cliff side where they've just excavated down through, and we have sedimentary rock, but you can see all these different layers and everything. And I always, or where they cut a highway through, I always end up at home just like, what happened? What the hell happened here? So I'm wondering if like you're looking at the various layers and stuff in the mine and just trying to figure out like what the hell.
Yeah, so just in your own mind,
on?
like, are you look like as you're doing your job, you look at something that you see in the mine or whatever in the open pit mine, and you're like, okay, how did this end up like this?
Oh, that's the coolest thing ever because you can see how there's different bands of contamination. So it's like you could have a volcanic host rock like rhyolite, and you'll have your magmatic body come in, but you can see the streaks of rhyolite where it was peeled away when the igneous body came through, and you can see it streaking through.
Oh, wow.
See some areas where it's like there was significant amounts of iron, right? Things like that, and they're stained with iron.
Yeah.
You can just see big streaks of quartz going through it, like things like that.
Yes.
It's like, oh man. It's like with the igneous bodies, they're so complex that you can sit there and look at it all year and just come up with different ways that this could have formed, right? Hypothetical methods of how this deposit could have formed, how it should have formed, but based on, say, this individual property here rules out that possibility, or you know what I mean? There's so many different combinations. You can just sit there and brainstorm.
Yeah,
like,
that's exactly what I'm talking about.
That's exactly what we're talking about.
The thing that the thing that blows me away about it every time is just. It seemed like we have this formation nearby that's a giant granite
bubble.
Yeah, bubble that's like protruding out of the sedimentary rock, and they say that it was shoved up. And I'm wondering, like, there's the idea that it was shoved up over millions and millions and millions of years or whatever, but still, it's just like what, like the mechanism that causes this process to happen is just freaking mind blowing to me. Like the turmoil that's going on.
Unreal, right?
Yes. Yeah. So
like it's impossible for us to really fully get a grasp on how these processes happen because they happen so slowly, right?
Yes.
One thing I like when I was talking to my dad about this a little while back. He's asking about volcanoes and stuff. And I'm like, well, you want to look at, he's asked about, there's a place in Newfoundland where there's part of the mantle's exposed.
Oh, wow.
So like, well, it's not like exposed right now, but I mean, it's called the Tablelands in Grossmorn. And it's an area where the piece of the mantle got exposed. It like buckled up from the crust boundary.
Oh, wow.
And just like little bubble of it came up there. And he's like, how did that happen? And like, he's like, I thought like if there was, he doesn't understand how magma would get to the surface. I was just like, it happens all the time. Like the Mid-Atlantic Ridge is constantly producing like magma, right? It's just like constantly expanding. So I told him with the whole concept of tectonic plates and everything, you have some that are going under other plates. It's like at the rate we're going now, I think the Mid-Atlantic Ridge is expanding at the rate that your fingernails grow, right?
Right.
So in human history, in the human time scale, I guess, whatever you want to call it, it's fuck all.
Yeah.
I mean, it's not really significant in terms, like you're not going to get significant growth in 80 years. But if you take that over 200 million years,
well, my fingernails are pretty long right now.
Change, right?
I mean, my fingernails get pretty long. I have to cut them. So
yeah. Well, so the next time you look at your fingernails, go, holy fuck, that much of the Atlantic
ridge,
just got
the
created,
ridge
right?
is just spread out that much more. Yeah, created that much more land.
I'm never going to cut my fingernails again.
You're just gonna have a Sharpie, and your fingernails are gonna be like meter
marked.
long.
I'm just gonna
dates.
I'm just gonna keep one.
Yeah,
and I'll just everywhere I go, I'm just like, yeah, that's how much more of the Mid-Atlantic Ridge has been created
since I stopped cutting this fingernail.
2019.
yeah. That's awesome.
Research project.
Yeah,
Do it for science.
hell yeah.
All right, we're going to take a quick break, and we will come back with Sheldon from the C Word talking about geology.
A little bit of mining bumper music right there with some hammers and whatever else. Brothers of the Serpent podcast. With forked tongues, we speak to annoy the Enlils of the world.
That's right.
And
With our babble.
yeah, that's right. So we're talking about geology here with Sheldon from the C Word podcast, all about conspiracies. So are there any massive conspiracies in the field of geology?
The big one. You know the real big one, I guess, like flat Earth.
Oh, yeah.
That's the absolute worst.
You don't think the science of geology supports a flat Earth?
I don't know, man. They make a pretty compelling argument.
Are y'all,
Yeah.
if y'all are going to do an episode on flat Earth, we probably shouldn't talk about that because we save your expertise to trash that theory later.
Oh, yeah. Oh, man. Jesus Christ. Yeah, let's. Flat Earth is the big one, you know.
Yeah.
Okay.
And most any other conspiracies regarding geology is mostly just dispelling any research that people have done.
So yeah, I was going to ask you, like you talked about how things take a very long time, but what do you think about like large catastrophes that are basically isochrons? Like the KT event, for example, that wiped out the dinosaurs.
Yeah.
So when you have a philosophy in geology of uniformitarianism, or basically that everything sort of takes a very long amount of time to take place, but then it's interspersed with these catastrophic periods of massive geological upheaval.
Yeah.
Are there, do you think that more modern geological science is taking that into account more and more and being able, because I've always wondered, so Kyle has said we're surrounded by sedimentary rock here. We're in Texas, right? So we're on basically what they call a shallow inland sea, a late Cretaceous shallow inland sea. So it's all sedimentary, but it's catastrophically deposited. Like when you look at the sediment, it isn't millions of tiny thin layers. It's enormously massive thick ones, and all of them are full of the fossils of things that were alive and buried alive, right?
Yeah.
So what do you think about that? Because to me, one of the big controversies in geology that has been going on for maybe 100 years or so is the fight between the catastrophists and the uniformitarians.
Yeah. I mean, like you said before, I think there's a good balance between the two.
Yeah.
Because you can kind of simplify it down with your even like everyday life. You look at everyday life, small changes happen, over time,
yes.
and then they turn into something. And then every now and then you get this big event that completely fucks your life up or turns it around, right?
Exactly.
Same thing. Why wouldn't it apply to rocks, right? So if you're looking at uniformitarianism compared to catastrophism?
Yeah, catastrophism, yeah.
Yeah. I mean, you look at the KT extinction event compared to, when you're talking about extinction events, it's a bit more drastic to go with. It makes a bit more sense to go with catastrophism.
Yes.
But uniformitarianism, I think, is more akin to... what am I trying to say here? More akin to slow formations of deposits. Very we have them here. It's almost like shaly deposits. You can see very thin layers.
Yes.
You can see that in the rock. It's fine. Even if they're a meter thick, though, it doesn't take that much sediment to make a meter of sediment, right?
Right.
And when you're talking on a geological time scale.
Right.
It's not like there's a layer every year. It's like a meter every 100,000 years types of deal, right?
Right.
Now, when you're in Texas, where you see the big, thick layers, right?
Yes.
That could be a large scale landslide, mudslide, that sort of stuff, right? Because you're not going to get large quantities of fossil, like a large fossil record with normal sedimentation. If you have
right, the stuff doesn't get buried alive when nothing catastrophic is happening, right?
Yeah, why? It'd have to be fucking already dead, right?
Yes, exactly.
Dang it!
What?
We've been walking around these hills for almost 20 years now, and Russ has been like, "This looks like mudslides. The mud just rolled down the hill," and I'm like, "Nah, I don't think that's what it is." Damn it!
Vindicated. Thank you, Sheldon.
Well, in the geological timescale, being wrong for 20 years is just like a blink of an eye.
Exactly. Exactly. That's my excuse.
Yeah. Geologists deal with large spans of time. So when you're wrong for 20 years, it's not a big deal.
Not a big deal. You're forgotten about. It's all good.
Yeah. We talk a lot on this podcast about those two different things, about the catastrophism versus the uniformitarianism. And I don't know if you've ever paid attention to any of the stuff that Randall Carlson has done, or Graham Hancock, how they've talked about the Younger Dryas. I know you studied the Younger Dryas, but that was a global catastrophe. I mean, it wiped out, what is it? It was all what they call the Pleistocene megafauna.
Yeah.
And, in a single generation, all these different, 70 species of large mammals were killed in the North American continent alone. But all over the world, there were massive die-offs. There's evidence of enormous tsunami or floodwaters coming in from the oceans and down from the melting ice sheets. So you live up there where the ice sheets were, right? It's one of my favorite places when I go visit my parents. There's a place on the highway where it's all just exposed,
just
scablands.
The glacial erratics.
Scablands,
Yes.
It's just glacial till, and huge boulders out on the plains where there shouldn't be any boulders, right?
Right.
It's one of the best parts of driving out to my parents' place, seeing the glacial till, all the upheaval and everything. It's just crazy. And then you just think this was covered by a kilometer of ice.
Yeah.
That's insane. Like you can't even fathom how thick a kilometer of ice would be, right?
Right. Or how much that would weigh.
Yeah, exactly.
Like how much weight, how much pressure was that putting on the landmass, right? And shoving it down into the mantle.
Yeah. Oh man, that's like a kilometer thick. That's fucked.
Yeah, it's incredibly heavy. I know that in some cases they were thinking that it might have been up to 2 miles thick in some places, like over Hudson Bay.
Oh yeah, but like when it comes to the Younger Dryas and everything like that, it's important to think of what caused it or what could have caused it, right?
Right.
So now they think that it was caused by, I don't know what everyone's stance is on the whole climate change thing, right?
Uh-huh.
But I'm I don't know what people think in the real world and stuff. I don't usually go out in the general public talking about this stuff, but we're pretty well on pace to have an issue like this in the future, the distant future, due to a shutdown or reduction in energy for the conveyors, the gyres and stuff in our ocean currents.
Yes.
So it's why England has a temperate environment compared to Newfoundland, even though England's further north.
Oh, right.
The
because
warm
the
water
ocean,
gets,
that's right.
It's a giant, almost like a conveyor belt, right? Transportation of heat and salt water. And as that slows down, you get really large discrepancies in the climate.
Yes.
So you don't have anywhere for the warm air to go. So it's going to sit around the equator, but your cold air is going to sit up further north. So you get places like Newfoundland covered with an ice sheet.
Right.
Or if not an ice sheet, that's a bit drastic, but you'll have issues where you're going to have no farmland, like in terms of human impact, be like no farmland. Your fauna is going to change. You're not going to have nice green forests. It's all going to go to tundra if it drops, severe enough, like with the Younger Dryas.
Right, and I think that so the Younger Dryas impact hypothesis guys are saying that they think that the Younger Dryas was actually kickstarted because the Younger Dryas is actually an anomalous reemergence of the ice age that had been previous to that waning for thousands of years, right?
Yeah.
So they were thinking that there was an impact event or maybe a bombardment event, multiple impacts that basically what did George Howard say that completely stopped the whole ocean current rotation cold, stopped that entire system.
Yeah.
And that caused the northern hemisphere to basically freeze.
Yeah.
And then 1,000 years later, something happened that was also catastrophic that started the system back up again, and then we had a massive melting.
Yeah, that's crazy.
Sorry?
I was just saying that's just crazy. Go ahead.
Oh, yeah. The impact event, that makes a lot of sense. So this goes back to the Uniformitarianism and the catastrophism.
Yeah.
Where you can kind of have both mechanisms hand in hand.
Right.
So you could have the impact event. They have evidence for some sort of impact event happening 13,000 years ago.
Yes.
So around the beginning of the Younger Dryas. Why couldn't that be the trigger that caused the shutdown of the ocean conveyor system, right?
Yes.
Why wouldn't that go hand in hand? So, I mean, but then again, we're looking at, it didn't happen over the course of a year or two. It happened over the course of hundreds of years, right? In some cases, it'll last for like 1,000 years or something.
Yes.
Yeah, the Younger Dryas period was like 1,000 years.
Yeah, just a little over 1,000 years long, yeah.
Yeah, 1,200. Yeah, 1,200 years. So, it's not something that, on a human time scale, it's not something we can really appreciate, even though this is one of the more severe, most recent and severe climate events that we have evidence for, right?
Right. So it definitely impacted the human population or whatever civilization existed at the time, if there was one. And we know there were bottlenecks in human population at that time period. So along with a lot of animal species.
Oh yeah,
that
yeah.
bottlenecks
But I
as
mean,
well.
like the fact that it was over, say, 1,200 years on a day-to-day basis,
Right.
it'd be harder to appreciate, like something we're going through now.
Right.
In say
Yeah,
200
except for
years
that-
time, it's going to be almost way more evident than it is now.
Right.
Right.
It's just the people that
Right.
were alive when the impact
There was that
happened.
one fateful day where they were like, "Oh!"
Yeah, those guys got to experience a whole lot of shit changing very fast over a very short
Yeah.
period of time.
They would disagree with what I just said.
Exactly.
Say what?
What do you mean it can't happen really quickly?
Yeah, but yeah. But I mean, like the whole worldwide cooling, that took some time for it to really start to get some traction to it, right? It didn't happen, in a few years,
Yeah.
minus the impact event,
Right.
Right. The geologists at the beginning of the Younger Dryas were catastrophists, and the geologists in the middle
Yeah.
of the Younger Dryas
Were
were
uniformitarians.
uniformitarians.
Yeah, yeah. They're like, oh, this is going to be my kids' problem.
That's right.
Yeah.
And the other thing I think is cool about that, and the whole just looking at that, the Younger Dryas process, the beginning of it, the end of it, and what types of things were happening throughout the planet is congruent with a lot of these stories in ancient texts about these crazy things that happened, like the flood myths,
Oh, yeah.
fire raining from the sky,
Yeah.
day turning to night. Like if you imagine and you're on one side of the world and the other side of the world is impacted on land with some large, chunk of rock or whatever from outer space, and then the whole
Yep.
it throws all this dust and stuff up into the sky, and then day turns to night on the other side of the world, but you didn't know you were hit.
Right.
Yeah,
And it also
yeah.
starts global firestorms of like anywhere around the impact, all the ejecta.
Fire and brimstone,
Yeah.
for example. There's just
Yeah.
it's just cool to think about all the
Correlations with ancient texts from all over the world of
And that-
stories of catastrophes. Yeah.
and those texts are dated, many of them, within the past 6,000 years,
yeah.
but they could have actually been
Much older stories.
telling a story that was much older. And in a lot of cases, we see that with different civilizations that copied texts from previous civilizations.
Yeah.
So I think that's a really cool correlation. But
Yeah, because I mean, it wasn't like you could just send information. Like information didn't get place to place quickly at all back thousands of years ago. It took generations, if not, hundreds of years for any sort of information to get to the other side. Not even the other side of the world, the other side of the continent.
right.
Yeah.
And if there was an event that was taking place in Europe or Africa or Asia, in North America or South America, they would never cross-reference that at all. Like, in terms of being like, this happened here, and because they didn't explore that until, like the Vikings came over and stuff. But
Right. So basically, what you're talking about is that if we're looking at ancient civilizations, and
Yeah.
we're going with the idea that they didn't move around they weren't nearly as mobile as we are now, and their communications were limited by either foot
Yeah, the
traffic
transferring
or
of information.
transferring of
was
information
extremely
was slow. So when you see some kind of climactic event correlated in texts across civilizations around the world, you have to assume that the event was global in scope, right?
yeah, that's true. Yeah, that makes sense.
Yeah,
That's one of the reasons why we like point to the tradition of Halloween. For
Yes.
us, it's Halloween. There are places around the world that call it different things, but basically the Day of the Dead or All Souls Day,
yeah.
it's sort of celebrated here in the fall, but on the other side of the world, it's not celebrated in the fall. It's celebrated in
It's on the same day.
Yeah.
But it isn't a harvest festival down
Yeah.
there. It's on the same day, and it's all basically a sort of a Day of the Dead, and that could be a very old transmission of
Yeah.
an idea of when almost everything died on the same day.
Yeah, that's pretty neat. See, I don't really think of it in terms of the like anthropological impacts, things like that, because that's not my scope. But it's really cool to see that side of it because I never think of it like that. Right? That's really cool.
Yeah, that's one of the favorite things one of our favorite topics on this podcast is we look at these ancient texts, or we look at these ancient civilizations, and we look at the things that they seem to be saying in their texts or their structures or their oral traditions that have been recorded, whatever information we have about them. And then there's these correlations.
You start looking at geology, and people that are, have studied and sort of documented these vast climactic changes on the planet, like the Younger Dryas or whatever, and everything that they're saying about what might have happened, like you said, there's a million different possibilities that you could come up with that caused this thing or how it happened. But what the actual data that they're looking at shows, like, for example, in the black mat layer, that there were these global firestorms, basically, that every green plant on the planet practically burned. Nearly everything burned to the ground. So you can see from that data the correlation to these ancient texts. It's fascinating.
Yeah, and then there's the flood stories, and most people, at least in the Western civilization world, most people are familiar with the biblical flood story, but there are thousands of inundation, basically water inundation stories in cultures around the world that are not connected with each other and spread out across time, that talk about enormous amounts of water suddenly appearing or pouring across them, and they have all these similar elements of, somebody was forewarned and they were told to climb a tree or a mountain or build a boat or dig out a canoe or hide under a rock or something. It's very strange how all these different disparate cultures that when you look at it with the standard model of archaeology, that they weren't talking to each other, and yet they're all describing a similar event. It seems like either, number one, they're all telling a story that's much older than their civilizations that they somehow carried down with them from some much older previous memory or civilization, or they all experienced the same global event in some way or another.
Yeah. Yeah, that's wild. That's really cool.
It's like you were saying, you're up there going through that area of the land, and you're looking, and it's just like, there was a kilometer of ice up here. And where did it go? And then I guess, I don't know if it was the beginning or the end of the Younger Dryas where the sea levels rose like 400 feet.
Yeah, 400 feet.
Yeah.
Yeah, that was at the end.
The end of the Younger Dryas.
Yeah.
So
they had been rising for a while, very slowly, because there was a warming that was correlated with the Milankovitch cycles. Right. So the ice age that had been going on for a long time, and correct me if I'm wrong on this, Sheldon, but the ice age that had been going on for a long time was slowly warming because of the Milankovitch cycle, and they've correlated that with the Milankovitch cycle. And then there was suddenly this anomalous Younger Dryas event where the ice age came back full force in the northern hemisphere, and lasted for 1,000 to 1,200 years, and then suddenly ended abruptly and dumped all this water into the ocean basins, and the sea levels rose 400 feet. And Sheldon, you guys actually addressed this on the Seaward podcast, where you're talking about Atlantis. You started talking about the isostatic rebound of the. You want to talk about that a little bit, because that was a really cool discussion you had, where you're talking about how all this water, all the weight of the ice pours off the land and into the ocean basins, right? And then,
I was absolutely plastered for that, but I'll try and give it a shot here. Oh yeah. So like you said, the weight of when we were talking about the ice being on the land. Yeah. So like that pushes the crust down. So that has, like you said, a significant amount of weight. So when that melts, that's released off the crust. So you're gonna have hold on, I have to get my thoughts together for this so I don't sound like an asshole.
Don't worry, we sound like assholes on this show all the time, man. It's a long tradition.
We have to have a watcher, to keep us from sounding like assholes. We have standards on this podcast. We try to get almost everything wrong.
Right? Yeah.
Not everything.
Almost everything wrong, not everything. But you can get almost everything wrong. Yeah, those are our standards.
But I didn't hear what you said. So you said something about the isostatic rebound.
Yes. So when the ice weight comes off the land, there's an isostatic rebound, right?
Yeah. Now I don't know too much offhand. Like I said, I was absolutely annihilate it. But so like when you're gonna remove so much weight off, it's like you're going to have some sort of. It's hard to kind of. It's kind of hard to. I don't know what I'm trying to say.
Well, how about I say this way? You said that you wrote a paper on the Younger Dryas, that you spent a lot of time on it.
Yeah.
Why don't you talk about that? Because that's basically what I'm interested in. What you know about the whole event? Okay,
so yeah, the Younger Dryas itself, we went over a large portion of it. It was a major cooling period in the. It was like 12,000, 11,700 years ago. And the big indicator, like you said, was due to, the hypothesis of the impact event.
Yes.
And that caused the shutdown of the thermohaline circulation of the North Atlantic.
Right. That's what it's called, yeah.
So the shutdown of the thermohaline circulation in the North Atlantic was a major impact, had a major impact on climate and not just climate, but the biodiversity in the oceans as well. So when you shut down the thermohaline circulation, so the heat transfer and salt transfer in the oceans, you're going to have stagnation. You're not going to have, say, your phytoplankton and things like that getting the nutrients that they need, and they're going to be in environments that they can't survive. So you're going to have major die-offs of not just, say, base level organisms or base level, I guess, food for the higher up creatures. You're also going to have an impact on creatures that are on the on Earth, is like on the
land as well. Yeah. So the thermohaline circulation you're talking about, that's a system that basically circulates the Atlantic waters and brings warm water up from the equator and cold water down, and it operates in some way as a cooling / heating thing that sort of spreads the temperature around, right? Is that how that works? Yeah. And it also stirs the water.
It's not just in the Atlantic, but like across the entire planet, right? So this is one of the major contributors to what causes certain areas of the Earth to be great for farming, some to be really prosperous for civilization, things like that. So that's why the Gulf of Mexico brings up warm water from south, brings it up to off the coast of Newfoundland. We don't get any of the warm water because it's always fucking cold here. But
I didn't know that. I didn't know that the ocean currents have that much of an effect on the whole global climate. That's really cool. I knew that they were a big impact on the ocean climate, but I didn't know it was global in effect. That's really interesting.
Yeah. So like if you had a major change to the thermohaline circulation, you'll have major disruption to your ecosystems worldwide. So one thing like that I researched when I was doing the Younger Dryas was the effect of the Younger Dryas on the thermohaline circulation, and what kind of effect that would have nowadays if we saw something similar.
Oh yeah.
So they're seeing now that there's a decrease in the transfer of energy or heat from the Gulf Stream from the south to the North Atlantic since the mid 1900s. So as you're seeing this reduction in not so much energy, but basically energy,
heat transfer
from the Gulf Stream up north, you're going to have a reduction in the amount of, a reduction in temperature, a reduction in the amount of, so when water gets saltier, it gets denser, so it has a tendency to, that's where you get like this circulation effect. This is what's called thermohaline, because it's based off temperature and salinity.
Okay.
So when you get your water's warm and it's fresh, so you get an influx of water, influx of fresh water. It's from like your glaciers melting.
Right.
So your salinity decreases. That decrease in salinity is a decrease in density. So it's not going to have the same effect to sink like the cold, salty water when you get up in the Arctic to go down and go below the warm water. So you know how if you have, you think of like heat transfer.
Yeah, cold will sink.
Yeah. So your heat, they say heat rises, which is, it's
Backwards.
a bit of a, yeah. But the hot water, the warm water is usually, it's not as dense because of the lower salinity. So like this, just think of it like, I'm not really good at explaining it, but just think of you have something cold and dense on one end, and then it warms up as it goes down around the equator, comes back up, pulls back down. It creates that almost like a gyre.
Yes. So
like as the discrepancy between the warm and the cold decreases,
the gyre slows down.
Yeah, your gyre is going to slow down, right? So if there's no, I guess, polarity in, say, your gyre, there's not going to be any energy, not so much energy, but not going to be as much transfer of warmth or water.
The motion is reduced, so the gyre slows down and stops.
So is this actually happening? It's actually slowing down?
Yeah. Yeah.
Okay. So a couple episodes ago, I had reported a news story on, it was based on the Little Ice Age. It happened in like the 1800s, or was it 1600s?
Yeah, 16 to 1700, something like that.
Something like that.
Yeah.
They call it the Little Ice Age, and it was basically there's this like random cooling period that lasted for a couple hundred years or something.
Right. And there was like the year without
is that like the medieval ice age?
Yes. So that period, like you were saying, when it cooled down, the farmland just, crops obviously weren't growing as well, and there was like a massive decrease in human population because of
famine.
People were dying from famine and starvation and all kinds of stuff. It was pretty rough. But this was incredibly mild compared to
an actual ice age,
the Younger Dryas, etc. But the interesting thing about the story was that these scientists were studying the deep ocean temperatures in the Pacific, I think, and they were finding they had learned, this study had produced and written a paper on the fact that these deep ocean temperatures are still cooling from that period.
Oh, wow.
So that kind of makes sense as to what you're saying, that if way, way down there deep where all that dense, very salty water is still cooling down, well, it's going to keep collecting and getting more and more dense, and that's going to slow down this gyro effect or whatever you're talking about.
Yeah.
It's like, so the different currents in the ocean bodies are called gyres. That's what I was referring to. Sorry.
Gyre. I
didn't explain
gyre,
that.
yeah.
Gyres. Okay.
Gyres.
So they pulled up all this data, the oldest data they could find on these deep ocean temperatures, and like these guys from the 1800s or whatever, they were taking these like hempen ropes or something,
lowered a thermometer down there,
and put thermometers on the end and just sent them way, way, way down there, and they were collecting all the temperature data from these deep oceans, and these scientists were taking that data and sort of calibrating it based on densities and other things to sort of fix the temperatures that the older scientists had collected based on the lengths of the rope that they were using and all kinds of stuff. They sort of calibrated those temperatures, and then they were measuring their own deep ocean temperatures and finding out that it's actually colder now than it was then.
Even though we're no longer in the Little Ice Age.
That's right. The Little Ice Age is over, but the deep ocean
is still,
temperatures are still dropping.
Oh, that's wild.
Yeah.
And I have to maybe the watcher, you could find.
So
I
think there was something, some conclusion in that paper that they were or maybe not a conclusion, but a suggestion that they were saying that it's not that the Little Ice Age is still in effect, but that effects are still reverberating through the oceans from it.
And they were, it wasn't so much a conclusion, but they were saying this is totally the opposite of what we thought would have been the case, and so we're going to have to like figure out what we've got wrong in our other models, and how is this happening?
Right.
Their conclusion was, what? How is this happening?
Their conclusion was WTF. basically.
But that's cool. Like I also had never really thought of this idea of that, so the salinity obviously makes it
More dense.
and then so that's going to fall to the bottom of the oceans, and then all the cold water is falling to the bottom, so the cold water is going to become saltier and saltier, and so they're taking these measurements and it's still getting colder down there.
Yeah.
So you could see that the cold water isn't. You probably now I don't really know. I didn't do any research on stuff nowadays in terms of ocean waters now, but you could think like if it's colder and denser, and if surface water is warmer, you think that would have an amplified effect, wouldn't you? If the difference was larger, right? So now, in terms of the Gulf Stream, that's where they found out that the thermohaline circulation is decreasing. Now,
well, I'm thinking that if the deep ocean temperatures are still cooling, that is evidence basically that the salinity down there is going to be increasing. And then, so a lot of times when you have this, I guess that just makes sense in terms of like the currents that you're talking about are reducing their activity. There's not as much motion change in the currents. So that could be the reason why it's still cooling down there, or the cooling down there could also be the reason why the currents are decreasing. It's either way. I don't know which way it would be.
Yeah, I'm not a
hydrologist.
I'm not a hydrologist or a climate scientist.
Yeah,
but
neither are we.
I would like to find out.
Yeah, I do think it's and the ocean has those thermal layers, right? So in some cases the currents don't cross the thermal layers because like the layers actually will sit, a layer below, like a layer will sit on top of this one, and there will be a big current in the one above, and when you get down, you drop through the thermal layer and into the colder one, all the water is not moving. So I don't know if that's the case of the Gulf Stream. I don't know how deep that one goes, but I do know that a lot of the currents that we experience or that we've measured that are closer to the surface are not taking place, or there are completely different ones that are taking place deep down.
Okay.
Yeah. I think we're up on a break here.
Yeah, buddy.
Yeah, we're up on a break. All right, we're going to take another quick break, and we will come back for the second half of the show with Sheldon from the C Word.
Currents.
And we are back. Brothers of the Serpent podcast with your hosts, Russ and Kyle, the Watcher, Brett, England,
Snake Bros all,
and Mr. Sheldon from the C Word podcast, joining us to talk all things geology. And we were discussing his knowledge of the ocean currents, the gyres and their effects on climate, and the theoretical effects that they may have been having on Younger Dryas, cataclysmic climate effects, and then what those effects might be like today. So we're back here with Sheldon, and the Watcher had a good question. Watcher, why don't you come on and ask the question that you had?
Wait, I had an invention just now.
Oh, wait.
It's a way to measure the gyres. It's called a gyroscope.
Damn it, why didn't they think of
Why didn't anyone think of this already?
You can get them on Amazon for $2. All right.
Damn it, nice.
Watcher, are you there?
Yeah, I was just waiting for Kyle's invention.
Okay.
At least it's not whale jokes. All right.
The question that I had talking before the break about ocean salinity and the effect that it had, that was something I'd never heard before.
Yeah.
So it really started the wheels turning.
Got new snake facts.
And my question was, so on the ocean floor, volcanism down on the ocean floor, like along the Mid-Atlantic Ridge, the Ring of Fire, wherever else lava comes up in the ocean floor, is that lava going to have like a high content of things that readily form salts like calcium, potassium, sodium? Are there formed salts in it because there's a ton of ammonia released in terms of waste from ocean life, and ammonia readily forms salts? How does that affect the salinity? Does that potentially do things to this whole cycle? And go.
Nice. Just throwing me out there, But yeah, so like I was saying, things that are most of the minerals that are formed in volcanic processes have an abundance of sodium, magnesium, salt, potassium, and calcium, things like that, aluminum, bunch of different, lighter to medium-ish weight metals. And these salts, they definitely do play a part in the salinity. But I mean, I mentioned previously when we were on our break that when you have the creation of these, say, saline materials, you also have the subduction zones taking in the same sediment, not the same, but taking in large amounts of sediment, salty, cold, dense water as well. So it almost would offset the accumulation of any sort of salt that would be produced in these zones.
Yeah, that's interesting. And I had never thought about the fact, but yeah, I had never thought about the fact that these subduction zones would also be like pulling the water down beneath the other plate as well. That is a fascinating concept. So how much water do you think could be, I mean, how much do you know?
Well, you got to think that the sediment's going to be saturated.
Yeah, absolutely.
Yeah, that's the thing. You're not actually just like sucking in water like through a vacuum. It's this cold, dense, salty sediment that's just been
accumulating
accumulating for
forever.
So my thought was that
millions of years,
Yeah.
or hundreds of thousands of years.
yeah, forever. Whatever.
Yeah, come on.
Forever.
Basically, what you're saying is forever. Yeah, come on.
Yeah.
In layman's terms, forever. Okay. So my thought was that this process could actually be sort of like an equilibrium, in the sense that if the bottom of the sea continued to get saltier and saltier and saltier, and of course, I guess would have to reach a point of saturation where you would have precipitating salts coming out of the water.
Yeah, exactly.
Which would then go into the layers of sediment and everything. So in a situation where you have this current going that's conducive to great farmland and all of these ecological systems around the world, but then the sea begins to get saltier and saltier for some, let's say one of these little minor catastrophes happen, and that starts to create this high concentration of salts in the sea, that perhaps the volcanic activity and the subductions, et cetera, sort of will equalize that. Well, they'll take these highly concentrated sediments and suck them down into the earth, and the volcanic activity that's coming out is going to be less salty than this highly concentrated salt. So it will just continue to try to keep it at this equilibrium.
Right. That's what he was saying, I think. Yeah.
Oh, okay.
The subduction is actually equalizing with the new salts being created at the volcanic areas.
Yeah.
Well,
So
yeah,
you'll get areas where it would, say, your oceanic plate would go under, and you'll have. So when it melts, it'll, the melt will slowly go up through any sort of fissure that it can, any sort of pathway that it can, until it comes out as either, volcano on the continental crust or oceanic crust, whatever. You'll have just, say, like partial melts coming up the whole way.
Yeah.
So these, like I said, typically with volcanic rock, it's high in sodium, high in potassium, high in your alkali materials, right? Alkaline material. So this is also why you'd find, like, if you're now this might make what am I trying to say? So when you're in volcanic zones with, say, old school mountain systems, things like that, you're going to get a lot of granites, a lot of rhyolites, a lot of dacites, andesites, things like that get weathered, and that sediment flows down into these. You're going to get large plains, right?
Yes.
So you get like sediment plains at the base of the mountains, and they're going to be fairly high in these alkaline minerals.
Right.
So this is where you kind of get that salt. So you can think of it almost like, you go back to grade school, you think of the rock cycle, right? You think you got your sediment, your igneous, your metamorphic, all this stuff. So when your sediment, it's all in equilibrium, that you're not going to be able to produce something that you don't have. Like if you are subducting a piece of crust that has, say it's just absolutely chock full of sodium, what you're going to produce from that when it gets melted is going to be chock full of sodium, right?
Right. So
if
you had
it's chock full of magnesium, it's going to be full of, you know what I mean? It's going to be a product of its environment.
So if you had a comet that was actually a giant salt crystal, that would mess everything up.
Yeah, basically what we need to do, people, is build rockets and shoot salt out away from us. It's bad.
The Earth is too salty.
Yeah. I like that.
Let's start a cause.
Just
man.
shoot it into the sun. You see what happens when sodium hits, when sodium gets kind of on fire, right?
Yeah, exactly. It's
Shoot
totally
it at
awesome.
the sun, and then we'll get hit.
Shoot it to the sun and put out like the best fireworks show ever.
And then we'll get hit by a CME, and we'll all die.
That's right. It'll be great.
Best way to go out, though.
Greatest fireworks show at the end of life.
All of civilization.
Yeah. That's awesome.
Yes.
I just all those freaking health stories that said salt was bad. I just never really knew like how detrimental.
They weren't talking
it
about for your
was.
health. They're just talking about for like the entire health of the planet.
Yeah. Salts are bad for everything.
They're bad for your heart.
But if you guys want to look at any more, if you want to look at any graphs or anything referring to what goes on when a plate gets subducted and some of the mechanics that happen after it gets subducted at certain depths, just look up back arc basins subduction zones, and you'll have there's plenty of graphs or there are charts that'll give you an idea what happens.
Okay. Backyard basins, is that what you said?
Oh, back arc.
Back arc basins. Okay. Watcher, take a look at that.
Yeah.
That's the Watcher's
Send us
job.
an email.
Yeah. So things, you're gonna get different types of volcanism happening, but the general consensus with the dense ocean crust is going to go under the, your continental crust or whatever you have there. It's going to melt, and then you're going to have a volcanic system based on what was subducted, right?
Ah, I see what you're saying. Yeah. Yeah. So the denser deep ocean crust goes beneath the lighter continental crust.
The lighter continental crust.
Right.
Yeah.
So it's subducted beneath it, and then your volcanism on the continent or whatever is being caused by that stuff that was subducted down into the magma. Very interesting. Oh, yeah.
So, I mean, that it's not just the... Ooh.
Revealing the
neat.
secrets of the freaking
That's
globe.
right. Revealing the
flat Earth.
geological secrets.
Talking about volcanism on flat Earth.
Yeah. Ooh, spicy. I like it.
The subduction part just actually is it just comes back up on the over. It's like a wave that comes over the ice wall back into the ocean.
Yeah.
But now I wanted to ask you a slight change of subject here. We're talking about things underneath the crust. The Mohorovicic Discontinuity, I think it might be called. What is up with that? Can you describe that or whatever you know about that?
So yeah, the Mohorovicic Discontinuity, or the Moho.
Yeah.
The Moho.
It's a crust mantle boundary there. So you have your oceanic crust, your continental crust, whatever you want to call it, and you have right below that. So when you think of the crust, I know when people think of the Earth's crust, they probably think it's fairly thick, right? But it's actually almost like an onion skin.
Yeah.
Right?
It's very thin relative to the size of the planet.
Like the brown onion
Yeah,
skin or the first white layer of onion?
Like the brown onion skin.
Okay.
Like the brown
Really
onion
thin.
Really thin. Yeah.
Yeah.
Flaky.
Yeah. So beneath the ocean crust, it's 7-10 kilometers deep before it turns into the mantle, or the mantle's there. And then beneath the continental surface, about 20, 30-ish.
Yeah.
Depends where you are on the planet.
Right.
But that's where the crust turns into the mantle. That area where the crust turns into the mantle is the Mohorovicic Discontinuity. Mohorovicic Discontinuity. So this is actually pretty cool, because in Newfoundland we have a spot where the Moho is exposed.
Wow. Oh, that's that place you were just talking about, like where it had been exposed?
Yeah, so there's a thing called orogeny where you have like mountain forming events, really. So these mountain forming events, sometimes it's usually the collision of crust, like continental crust on continental crust, or subduction zones where you get ocean arcs that collide with the continental crust and come up over, things like that, right?
Yeah.
Any sort of
Causes folding and stuff like that.
yeah, any sort of event where it's not going to be, it's never smooth like in the real world, but
Right.
when you have these small accretionary events and things, sometimes, well, very rarely you'll have the crust fold up. And when the crust folds up, it'll expose just a small portion of the mantle. So this has to be like a pretty intense event, right?
Yeah, that's crazy. Holy shit.
Yeah, so there's a place in Newfoundland where I'm from. It's on the west coast, and you can actually see the mantle rock from the Moho, like on the Earth's surface.
Holy crap.
Yeah,
That's wild. So go ahead.
yeah. So it's really the Mohorovicic discontinuity really is just the boundary between the crust and the mantle.
Isn't it somewhat mysterious that it is it's such an abrupt change?
Yeah, so yeah, because the thing that I guess makes what I'm trying to say is how they discovered it is when they did seismic work on it.
Right.
There's a huge change in the speed of the seismic waves.
Oh, yeah.
So yeah, because that's how they found out that there's
it's just
different layers
sudden,
to the Earth.
right? It's
Because
just
obviously
sudden.
they can't drill down that far.
Right.
Yeah.
Right. So,
So-
seismic waves are bouncing around down in there, and there's this sudden change that is showing them, giving them a map basically of this discontinuity where you suddenly change from a liquid magma to a solid crust.
Yeah, exactly. So, and like that's another thing is that so when we go through school and everything, you probably learn that you get the crust and you have liquid mantle, then the liquid outer core, and then the solid inner core. But
Yes.
it's almost like the mantle is almost like plasticky, right?
Oh, right.
It's like a ductile material. It's not quite liquid, not quite solid, right?
Right.
So
It has a
When he-
viscosity, basically. Is what
yeah,
you're talking about.
exactly. So when this guy did his seismic work, whenever the scientist that discovered it, he found the speed that he was receiving. So he had a seismograph, and he could send off some charges and get his seismograph to get the readings. He'd noticed that there was these really strange velocities coming back. So he would get the readings back, and they'd be like, it would be like, I think it accelerated really, just increased it in velocity.
Yeah.
As soon as it hit like this weird depth, and they didn't know anything about it at all, so they're like, what the fuck is this?
That's probably what he wrote as far as his thesis, like right before he did the final draft.
Yeah, so
Well, what in the fuck is this?
he's like, yeah, it was going this, it was going pretty good until it hit a certain depth, then it all just went to shit.
Yeah.
But like,
So it's weird to me that the thing that's weird to me is at how sudden that changeover is from this solid, incredibly dense crystallized rock to this, like, whatever you're saying, this viscous,
Gluey
sort
plastic material. Yeah.
It almost seems like you should have more of like the hardness slowly like grading over to this other.
Yeah, that's why they thought it was a mystery, right? Is that it suddenly changes instead of there being a gradual shift. So
Sorry, can you repeat that? I didn't.
Oh, I'm sorry. Yeah, I was saying that's kind of why it's a mystery that instead of there being a gradual change from, more solidified rock into it's slowly shifting into towards a more liquid type stuff. There's this sudden abrupt change, and that's why it's that's why it's a mystery, right? Why does it do that?
Yeah, that's why it's so strange that they were just expecting a typical gradual shift.
Yes.
But here it was just like it was as if it went from solid to ductile fairly rapidly, which it did, right?
Yes.
Well, as far as we can tell.
Right.
But they say, so the thing is, the Moho itself compared to the mantle and the crust is not very thick. That's the thing, right? So that's why it's like you'd expect this transition zone to take place over, say, if the crust is 10 kilometers, you'd expect it to take place over, and the mantle is what?
Oh, the mantle's
2,900 kilometers or something like that.
Yeah.
You'd expect it to take place over several hundred kilometers, or at least 100 kilometers, but actually it only takes place over like less than a kilometer.
Right. So are there any ideas on why that is, or is it just still a mystery?
As far as I know, it's a mystery. That's more like a geophysical type thing, like seismology and everything else is like geophysics, but
okay. Yeah.
Not my I guess.
Yeah, no one's mining down there in the Moho.
No, exactly. No, exactly.
It's like it's. I guess the mantle is like considered plasma. Is that right?
No, it's not
Or
plasma.
Not plasma.
Plasma is the sun.
Magma. I'm sorry.
It's magma. Yeah.
Yeah.
What am I thinking?
Plasma science.
Yeah. I was just thinking in terms of phase change, because you can't have like a midway between a gas and a liquid. It's just either one.
Right.
So it's kind of like that in a way.
Right. I remember you saying that before when we talked about this a while back.
But it's not really a phase change.
Yeah.
It's, I don't know. It's just weird.
Well, it may be that there's something like as pressure and temperature gradually increases as you're going down through the crust, eventually you hit a point where the phase change is now beyond where it must be something else, and so it is, right?
So like, yeah, you get like when you hit the mantle, it's like that's the thing is that it's not. You'd expect it if there was a large change in, say, viscosity or anything like that. You get a change in density, but not a real big change in. Well, it has viscosity is the big thing.
Yes.
So you go from solid crust to something that has viscosity, but it's not a liquid.
Right.
Yeah. So you get that like it's just like almost like a plasticky ductile material that you would expect to be solid, right?
Yes.
Or you'd expect it to be like one or the other.
Right.
So that's the weird thing. That's why it's kind of like a mystery.
Yes. I've always thought that was an interesting mystery. The whole Mohorovicic discontinuity is very strange to me.
It's the Moho, bro.
The Moho.
Oh, bro. Now, if you got like a guy that is like in academia and stuff, he'd probably be able to just shoot me down right now, just like kill me right where I stand.
Screw that guy.
But I mean, for the amount of stuff that you usually learn, like, I mean, yeah, I'm not gonna go and spend my life's work studying the Moho. I mean, I guess, but
Yeah, you can go walk on it just like a couple of miles away, right? Why do I need to spend all this time looking at it?
just pretend like the disclaimer in the beginning of every C Word podcast is on whatever you're saying right now. It's fine.
Yeah.
yeah, I'm pretty sure, like, yeah, Matt says that you're not gonna get any like good facts or any useful information. Like, come on, if you're looking for solid numbers and
You're in the wrong place.
You're in the wrong place. Yeah, come on.
I love that.
And I'm not here to do any false advertising. I'm just like what you see is what you get. You know?
Yeah.
It's a good thing you don't have a camera on you because I can't even see you. So.
Yeah, I literally just put my arms up in the air.
waving them
Like,
around first.
like-
yeah.
Yeah.
Yeah, we love the C word. It's very entertaining. You guys are
I'm
hilarious.
glad you like it.
Yeah. That's one of the reasons why I was like, we got to borrow. Kyle was like, can we borrow their scientists? And I was like, I'm going to ask them.
It's not even like I'm human. I'm just a tool.
Yeah, exactly. I was like, I promise he'll be fed and watered at least once a day.
Can we take your thing?
Yeah. Can we borrow your scientists for a little while?
What's the name of the guy that was giving you all this shit about about the colors of rocks and stuff?
Zach.
Yeah, he starts out nailing you just like, yeah, they're colored rocks. Who cares?
Yeah.
And then like near the end, he's like, this is like the greatest contribution to any podcast that you've ever.
Yeah, he's like, you totally made up for not being here for the last one about the reptilians. Yeah.
Yeah.
Yeah. So he gave me some
Meanwhile,
props.
I don't remember any of it. Like, when I listened to that podcast, I don't know what I said. You could have said it was someone else and put like a voice changer on it, and I would have been like, man, cool. Nice, dude.
That guy knows what he's talking about.
Right on.
Yeah, you guys are brave, man. Our episode 1 mysteriously vanished after I drank almost an entire big bottle of wine while we were doing it.
Mysteriously vanished.
Yeah, I was just like,
See, I don't have any say in what gets aired. I don't do any of the editing.
Yeah.
Yeah, if you go look in our feed, you scroll all the way back to the beginning, it starts out with episode 2. Episode 1 does not exist.
Yeah, and so I made my first rule for myself, which was no wine during podcasts.
Yeah, do not get drunk.
And then I broke that rule one other time,
Yeah.
and I hate it.
Oh man.
I had no idea that you were trash during that episode, so I think you did a good job.
Awesome. Nice.
Yeah.
I think that's my greatest contribution is that no one could tell. Or is that a bad thing? Do I just sound like I'm shitty?
Like you're drunk all the time. You sound totally the same, bro. Trust me.
Sick. Yeah, I'm like halfway through a fucking 40 now. I'm fine. But yeah.
So, what do you think about did you look at all about the recent crater discoveries beneath the Greenland ice sheet, the Hiawatha crater? Did you see any of that stuff?
No, I didn't keep up with that.
Okay.
Hiawatha?
Yeah. So the Hiawatha Glacier on Greenland is partially covering a 19 to 20 mile wide crater, like impact crater.
Holy shit.
Yeah, and it's fairly recent. They're saying, I mean, they gave it, the typical geologists are like, well, was somewhere between the past 10,000 to 4 million years ago, right? That's the window that we're
yeah.
Yeah, that's helpful, guys. Thanks. But basically a Pliocene impact, right? But it seems to be far more likely that it was much more recent because the ice has yet to scour the bottom of the crater. In other words, the bottom of the crater is still really rough, and you would expect that the glacial ice would have scoured it smooth if it was very old, right?
I'm actually, I looked it up. So I looked it up and I went on Wikipedia right away as soon as you said that.
Yeah.
Right? And it literally says, evidence suggests that the crater was created after ice covered Greenland 3 million years ago and perhaps as recently as 12,000 years ago. You weren't even making that up, dude. That was wow.
Totally not making it up, bro.
I could literally throw out a random number and be right on the money with what they're saying.
Yeah,
shit.
that's a huge window, and it doesn't help us because if it was as recent as 12,000 years ago, that impacted humans.
Yeah,
and probably had
And lines
some
up with the
Younger Dryas.
yeah.
Yeah.
So there is not as yet field evidence to show any more definitively how old the crater is, but it's looking like it probably happened very recently, and it may have been a part of a series of bombardments that caused or ended the Younger Dryas itself, and it happened in the right place in the ice sheet.
Interesting. That's cool. It'd be cool to see what the composition of the rock is right below the ice sheet. see if there's any of those. What do you call it?
Well, there's crater structure down there for sure.
Any of the material that's formed as soon as the impact hits the surface?
Shocked quartz and all that stuff.
Yeah.
Yes. Yeah.
Their melt glass and stuff.
Yeah. Yep. And
they have yet to do cores on it all the way down, but I think that's in the plans.
Yeah.
Now.
They just discovered it. They got to go through a whole bunch of shit to even do any work on it.
Yeah.
Yeah. Right now, I think the main stuff that they're studying is from this sedimentary sort of this under glacier river that's coming out.
Right, the water that's coming out from underneath.
It's coming out from underneath the glacier that has these bits and pieces of stuff from inside the crater in it that they're studying.
Yeah,
and
impact proxies in there.
And I think this is a NASA project. But so I'm sure they're planning to do some cores, but.
Yeah, wow. So I find that kind of stuff interesting because anything that recent, like 20 miles, is a big crater.
Yeah,
that's a big one.
When you said 20 miles, I
not the size of
there sometimes. So I'm looking, like I said, I have the Wikipedia page.
Oh, you don't know miles?
No, I honestly don't know what a mile is.
Oh, get out of here, man!
I don't know what a kilometer is.
No. It's 1,000 meters, man.
A mile. Hey, look, a mile is 1,000 paces.
Yeah, it's easy.
1,000 paces.
So so if you go outside your house and you walk in a straight line, 1,000 paces, you've gone approximately a mile.
Yeah, and one pace is 2 steps. So right foot, left foot is 1 pace.
So what's a step? So there's no actual like hard and fast rule on what a mile is.
Well, it is. It's just like the average. Yeah, the reason it's called a mile is because it's mil. Mil as in 1,000. Roman
1,000
mil.
paces.
1,000 paces. Yeah, 5,280 feet.
So there's it's definitely specifically defined, but it's based on the human. It's based on the human body.
Yeah.
The good old days when they didn't need numbers. They didn't need to be exact, right?
That's right.
Yeah. Yeah. If you were 5'2" and you took 1,000 paces, you roughly win a mile, basically.
Let me ask you something, you metric. How many
6
paces
months.
are a kilometer?
How many? You got me.
Okay.
You got me.
Yeah. GFY.
How many paces? I'm gonna say like 620 paces, maybe.
It would be 666 to be exact.
666.
Devil's number system, the metric.
Metric system's evil.
It's a freaking conspiracy, man.
Yeah.
So going back to the impacts, like I think that the data that's coming out more and more about, like, they've also found a big crater structure. Now this one's also much more difficult to study, called the Burkle crater structure in the Indian Ocean. And that one's enormous, 30 miles. I don't know how to translate that into kilometers, but basically a very large object hit in the deep Indian Ocean and basically impacted into 2 miles of water.
Holy shit.
And they're thinking this might be as recent as 6,000 to 8,000 years ago.
Wow.
Yeah. And what's fascinating is if you get on Google Earth and you look around the coast of Madagascar, the west coast of Madagascar, and then all the way across to the east coast of Australia, you can see, if you're kind of zoomed way out on Google Earth, you can see enormous tidal wave or tsunami patterns far, far inland from the coasts, where this enormous splash event from the impact through water, 600-foot waves basically, and made enormous deposits all across Madagascar and Australia.
That's wild.
Yeah. Okay, the watcher says 30 miles is 48.28 kilometers. There you go. Thanks,
Put
watcher.
it in terms I can understand.
Yeah, a 48-kilometer wide crater in the Indian Ocean is pretty big. And so what I'm basically getting at here is that these recent geological events that are catastrophic, and that's what we want to talk to you about on the last segment, which we are going to do after we take this break.
Cool.
Funky Bass by Daniel Phillips. And yours, well, I didn't play the bass, but some funky music for your enjoyment.
Some funky bumper music.
Funky bumper music. Daniel Phillips on the bass. Feet. Anyways, we're back. Brothers of the Serpent podcast. Here with Sheldon from the C Word podcast. Conspiracy podcast. And we are talking about all the massive conspiracies that we're not going to discuss on this podcast.
Well, what I was talking about before we took the break was all of the new craters that are being found.
Yeah.
And how they seem to be very recent. And I just wanted, I mean, like, obviously, this is all very new. So I just wanted to hear your take on what you think about how this might change the overall uniformitarian view of geology, that these global cataclysmic events like extraterrestrial impacts are much more frequent than we have thought for a long time. So what do you think about that?
I would say, yeah, that makes sense. And if you like, I said at the beginning of the show that you need a balance between both.
Right.
Like uniformitarianism is a good concept for the long term, like your geological time scale type of stuff. But then you'll have events like we just talked about an impact crater that happened between 3 million and 12,000 years ago.
Yeah.
Like 12,000 years ago was not that long ago.
Right.
In a geological time frame. So is uniformitarianism actually almost like a composite of multiple catastrophes over a long period of time?
Oh, okay, I see. So the uniformitarian view would be that you have a long series of catastrophes interspersed.
Or, I mean, it depends on how you want to look at it, right?
Yeah.
So uniformitarianism could just be like normal geological processes happening, or that combined with a series of catastrophes that happen on a semi-regular basis.
Right.
Like, do they take that? Some could take that into account. I'm sure you have some hardcore uniformitarianists that
don't like
say
it.
No.
Yeah, they don't like it.
No, but then you have catastrophism, where you think that major changes only happen because of catastrophe.
Yeah.
Which, I mean, I think some of the more extreme examples, so like say impact craters, large scale extinctions that happen
Yes.
fairly rapidly, I'd say that would be attributed to catastrophes. But I like the concept that these things happen frequently. Like we had a volcanic eruption back in, I don't think I was alive, but back in the 80s.
Yeah.
Was it like Pinatubo or something? I don't know if that was the one, but it was the one that dropped the global temperature by a degree or two for a year.
Oh, yeah, the year without a summer.
Yeah.
Yeah. That's right.
Yeah, so like that was only, that was, 1991. So yeah, I was a real young dude. But like,
Yeah, it's like 30 years ago, basically.
Yeah, that wasn't long ago, right?
Yeah.
That had a major impact on the climate. These things happen frequently. So to go off and say that uniformitarianism is, or like, because they call it a doctrine of uniformity.
Yes.
Like, so that's pretty naive and absurd to think that everything happens slowly and constant, right?
Right.
That's pretty naive to think, right?
Yes.
That
Yeah.
it just happens on its own sort of thing, right?
Right. We completely agree with that. And that it's been strange to me because like where we live, at least, there's evidence of catastrophe everywhere. I know this isn't the case all around the world, but where we live here, we basically live on like we say in the intro of the podcast, nestled amongst the dusty bones of an ancient seabed high atop the Everest Plateau. So we're on this massively uplifted plateau that used to be deep underwater that is covered in enormous deposits of fossil life that were obviously buried alive. They were not dead.
Yeah.
That was an enormous catastrophe, whatever it was. So.
But another thing is, well, on the flip side of that, where I live, it's an island that's, we see a lot of constant erosion, a lot of weather. It's a slow and steady progress. And we even see some exposed beds in one of the hills here. And you can see them, they were uplifted and eroded away to see. You could see the beds very clearly.
Yeah.
But there's no large craters. There's no large scale like impacts. There's nothing, no big landslides. There's no huge fossil life here or fossil record here besides the stuff down on the southeast coast with Mistaken Point.
Yeah.
But
okay, I have a question though. Couldn't that be partially because like less than 10,000 years ago you were under a kilometer of ice? So your landscape has to be fairly young no matter what, right? Because it was generated by the ice.
Yeah, I mean the rocks are old, but
right, yeah.
The fact that but that's the thing is we were covered by a kilometer of ice. I can go back to the geological time scale and say, was that a catastrophe? Was that because, it was covered by a layer of ice, but it wasn't like that for hundreds of millions of years.
Right, yeah.
I mean, it all depends on your frame of reference and your, what you consider to be a long time.
So it's a good point. There's gray area. Like we've often on this podcast talked about these two schools of thought.
Yeah.
And that sort of in the context that one, takes the place of the other. But really what you're saying is, I think, correct or more accurate that you have this general idea or this general concept of the way things happen, and that is uniformitarianism, and that it is interrupted periodically by the other concept, which is catastrophism. So you can look at these extreme examples of things around the world, like the craters, for example, and say, well, okay, some catastrophe happened here. And then the question really is that how broad were the products of that catastrophe? Like how did that catastrophe change the landscape in all these other areas? And then you can, for example, we have the Grand Canyon here, which is one of these debated formations.
Right.
So
was it a uniformitarian formation or a catastrophic one?
Right. Everywhere you've got this, this basically hilly, slightly mountainous land or whatever, and then suddenly there's just this massive chasm that's 2 miles deep.
Yeah.
And there's a tiny little river running in it. And the uniformitarianists would say, well, that river over millions and millions and millions and millions of years carved this massive canyon. And the catastrophists would say that perhaps that canyon was carved in a very short amount of time, and then the vast amount of the removal of sediment and rock and whatever from the canyon happened very quickly in terms of geologic time periods. And then the rest of it, way down near the bottom was slowly eroded away, or the sides were eroded away by precipitation, et cetera, et cetera. So you can have this combination of the two. But I think that the real debate or where the debate gets heated between these two ideas has a lot to do with the idea of evolution.
Yeah.
So
okay.
Evolution requires uniformitarianism without catastrophe.
Right. Catastrophe disrupts an evolutionary process of linear development of species from less complex to more, because a catastrophe wipes out the most advanced ones, technically speaking, like the megafauna from
without any sort of a catastrophe could wipe out the most advanced without any sort of preference or preferential treatment, right?
Right.
There's no natural selection in a catastrophe.
Right. Basically, if you throw in if you sprinkle large global catastrophes into the uniformitarian picture of the Earth, you end up with the quote unquote most adapted species being something like a cockroach, which will survive everything that happens. Some of them will survive, right? In other words, like the megafauna from the Pleistocene that were wiped out in the Younger Dryas period were the pinnacle. They were the best adapted. The mammoths, and they were around for a long time, and then they all died. And they were the most advanced, really badass species, and they all got killed by, in other words, the uniformity is good for evolution. Catastrophe is not. in the long-term scales that you're talking about, right? Because when you look at the long-term, catastrophe does not paint a good picture for the process of evolving from less complex to more complex life forms.
No, definitely not. But one thing, like when you said that thing about the river carving, a small river carving the Grand Canyon, that's a very romantic way for people to look at things too, right? So people are going to be more inclined to go with that and think that that's the way life is. People think that things happen gradually, you know.
Oh yeah,
that little things can make a big difference when realistically you can get knocked on your ass right away.
Right.
You know, people have an I don't know, they have an affinity to go towards things to make them feel better. Right.
Oh yeah.
So that's one way of
that makes sense.
Making the uniformitarianism
is comforting
point of view to
Absolutely, it's comforting because if yeah, it's like we're all gonna die. It's not very comforting.
No. I got a friend who like he'll just say sometimes like, so what do you want to do? And he'll be like, I don't know, what, it doesn't matter. We're all gonna fucking die. Like, there you go. There you go. Cool. Yep.
Yeah,
that's
very defeatist.
Yeah.
But it's a good point too, because you know, kind of the way I look at it is like, well, if that's the case,
let's do something
let's
awesome.
do our damnedest to make sure that doesn't happen. Let's dig up all the fossil fuels we can get, burn everything, and
get out of here.
Let's go.
Because otherwise, we're all gonna die.
Yeah.
Yeah, I think that the intersection of geology and archaeology is interesting, but the intersection of geology and excuse me, got a cough here. The intersection of geology and evolutionary science is also fascinating because I think that has been one of the main resistances to the catastrophic evidences. It disrupts that entire story about how life has developed on this planet.
Yeah, well, I guess one thing with the whole evolutionary standpoint with the catastrophism is sometimes you need to change things up.
Yeah, you got to stir things up.
Yeah, like sometimes you need a catastrophe. So if you have, like, look at the dinosaurs. If things kept evolving in terms of the dinosaurs, you'd have creatures that you wouldn't be able to sustain on the planet, right?
You'd have reptilians, right?
Yeah.
Yeah, if the dinosaurs hadn't been wiped out, they would have gotten intelligent, and there would be reptilians, right?
Who said they didn't?
Right.
But like you had very like large creatures that were becoming, you know, more and more complex. They're becoming larger and larger, consuming more and more, you know, greenery. But something had to change, right?
Yeah. Well,
so,
if it didn't change,
catastrophe allowed for the creatures that survived to thrive when they didn't need as much, you know, greenery as much. The fauna didn't have to be as large. The temperature didn't have to be as warm.
Yeah.
So they were able, so realistically, who's to decide what species is superior?
Right. So the natural selection works to a point. You know, it works. Yeah. It works in those long-term areas where between catastrophes. So you can have this development period. And all of the species that are living side by side that sort of work with that ecosystem, then it's disrupted, and whatever life is able to withstand this catastrophe, which is sort of random. It's like throwing the wild card in there.
Yeah.
Then that life form continues the process, and then new ones will develop around it, and it happens over and over and over. So you have this more dynamic evolution, basically, but. Another major issue with it is that the timescales that evolution requires for these changes to take place seems to be in conflict with the frequency of catastrophe that affects the globe.
Right.
Yeah.
On a large scale. But I thought slightly changed the subject that your point about the ecosystems in the microbiology and these currents in the ocean is another interesting thing, because
with the salinity of the oceans and everything else, and the sensitivity of their ecosystems.
Yeah, and you're talking about the phytoplankton's not getting the right nutrients if the currents aren't going.
Right, and
plankton is like food for everything.
Yeah.
Like plankton feed everything that feeds everything that
food
feed
of
us.
the gods.
Yeah.
Plankton is food for food that's food. Yeah.
Yeah.
And whales.
It's just crazy thinking about that system right there. Like what this idea of salinity that might disrupt this system and change that whole ecosystem within the ocean, and then that impacts the whole globe in that way. It's like, we were talking about in a previous podcast the fact that these viruses, there's just billions of viruses or whatever that are impacting bacteria and all this stuff, and there are tiny ecosystems in the oceans, whole species of bacteria that flourish and then die off and go extinct, and we don't even know it. It's happening all the time, and viruses are going in there and changing DNA and just constantly.
Something absolutely game changing could have happened, and it just died off.
Yes,
right.
Like that's
yeah. So this one type of bacteria that had whatever ecosystem it was surviving in, or even providing the survival for all these other things that are affecting the plants and animals on land, suddenly dies out due to some weird bacteria mutation.
Yeah.
And then that just changes the course of evolution forever. And
right.
we would never know. And there's no way to really quantify how this is happening all the time. So that's what that made me think of. Those just the simple fact of these ocean currents changing, or the density of the water. It's just that just freaking blows me away, man.
Yeah, it's weird. That's something you don't ever really think about. Something you'd never really consider. A change in one parameter in the ocean water could have a major, almost like a cascading effect over a lot of life that we know, right?
Right. A butterfly effect, basically.
Yeah.
Yeah. And I think
Ashton Kutcher.
I think of diatoms as well. Like diatoms are one of the ways that I know it's a specialized type of dating, but people use the diatomaceous content of different strata to figure out how old that strata is, because they have dated the species, right? So we know how long that this species was around, like basically roughly how long ago it showed up and then when it disappeared, right? And so when you find it in undisturbed strata, you can say, okay, that was within this time period of this species being alive.
Yeah. Well, that's same thing with pollen is a big indicator.
Yes, pollen, yeah. Pollen and diatoms. Tiny little microscopic things you can do. But I love diatoms because they're like little bacteria that build crystal spaceships around themselves.
Yeah. That's a good way. There's actually a industrial mineral product called diatomaceous Serpent.
Yes, diatomaceous Serpent.
All it is.
That's right. It's just the shells of diatoms. It's
And
it's millions of spaceships.
It
I also
looks
like
like
to
they're
eat
from
it.
outer space.
Yeah.
I like to eat that stuff, actually. I buy the food grade kind and I eat it
Yeah.
every day.
It's good for the gut. Yeah. Cleans you out, buddy.
Yeah.
What are you doing there? Well, I'm eating a billion tiny microscopic shells of dead animals.
Yeah. I'm eating
That we're supposed to go to outer space.
That's right. I'm eating a billion microscopic crystal spaceships.
Yeah.
Yeah, that's
Let's
another
blast
weird
off.
thing is that they are the main, one of the main producers of oxygen
Yeah.
that we're breathing.
Yeah.
Yeah.
You don't really think about that stuff, eh?
No. Sometimes we do. Like right
Yeah.
now.
Well, I mean, I shouldn't say you guys, but most people don't think of that kind of stuff.
I was
And
watching.
There's a lot of. It's kind of interesting how it all just ties into. Just one little change can have major effects on everything, right?
Yes.
So that's why, I know.
So we're basically
I know.
skirptards by saying, humans driving cars around are not necessarily destroying the planet.
Yeah.
So we
Depends
might-
what you want to. It's destroying it for humans. I mean, it's going to make. That's what I was going to say is the fact that even changing the CO2 content in the atmosphere on such a short time scale, it's going to have cascading effects.
Yes.
We don't know what the effects are.
Right.
We can infer, but
Yeah.
you don't know for sure what's going to happen in the future.
That's right.
So
it could get better. It could hit a plateau, or it could just completely take off. You don't know.
Yeah. Right. And there are so many other factors, but we're definitely changing things. We just don't know which of those changes or how big that change needs to be to hit a threshold. And
that's the thing is, global warming is a bad term to use too. Like climate change, it's going to change the climate now, for better, for worse.
Yeah.
Depends where you are, really.
Right.
And we also
from where you
in
are,
Newfoundland, I'm probably like just crossing my fingers.
Right. You can't get worse from up there, right?
Why aren't we using coal? It's fucking minus fucking 30. Shit.
Right. No matter how the climate changes, it can only get better up there, right?
we're just
It's
trying
not
to
getting worse.
we're just trying to help you prevent that Laurentide from building back up. buddy.
Yeah. Yeah.
Fucking right.
You don't want that Laurentide up back on top of you. You're going to be under a kilometer of ice, bro. And then you'll be the next like Antarctica breakaway civilization that people talk about thousands of years from now. They're like, there's people living under that ice sheet. No, there aren't. Yeah, they are. They're Newfoundlanders.
Yep. In the future, Alex Jones will be like, those goddamn Newfoundlanders.
They're still living under that ice sheet.
Living under that ice sheet. They've been doing it for thousands of years.
Yeah. Oh my fucking god. They'll find all the preserved. Like, there's a delicacy here called salt meat, and it's literally just beef soaked in brine.
Yeah.
And it gets like vacuum packed or put in a bucket. They'll just find that's what they'll find. That's the evidence they'll find.
Vacuum packed salty
meat. Salty brine beef, still vacuum packed because it's covered in plastic, so it's going to be good for at least 1,000 years. So
And maybe
that's going to be our fossil record. You know how we were talking about shit before?
Yeah.
In the sediment, no, we're gonna have salt beef. That's our contribution.
occasionally they'll find a bubble car wrapped around a moose.
That's right.
Yeah. Yeah. Maybe there were people here. Why would they drive into a moose?
Why would they drive this bubble into a moose?
Yeah.
Yeah. Well, you have anything else you want to add?
What's the craziest thing that's ever happened to you in the mining business?
Yeah, that's a good question.
That is a good question.
Found a giant glowing crystal and
Oh, okay. I just realized this other question I wanted to ask you about, which is heavy metals like gold. You were talking about quartz veins and stuff like that in the rock, and gold being in quartz and all that kind of stuff. And why? I don't know if you have an idea about this, but why are all these heavy metals in these crystals on the surface of a planet where heavy things should fall to the bottom?
yeah, it should sink.
What do you mean should sink?
Like in other words, like that, you expect the heavy elements to be deep as opposed to on the surface, because it's like the lightest rock is what ends up on the surface, right? Like the crustal plates are light is relatively not dense rock. So why is gold?
Yeah, it's a lot less dense than the nickel iron core.
Right.
So why are there veins of quartz with gold all wrapped up in there? Like, why are there veins of gold inside these rocks? That the rock is so much lighter than the gold. What is the gold doing there?
The concentration of those these deposits is just by chance that there's any sort of economic value of the gold being there. So it's a very small amount, so it gets circulated. So think if you had a slurry of, say, a bottle of water with and you put a scoop of dirt in it.
Yeah.
You shake it up, and it's constantly in motion. It's never just gonna settle out, right? It doesn't stop. These things, like the mantle's constantly convecting, right? So it's constantly moving. There's constantly magma being moved all around the planet, like through the inner workings of the planet. So you're never going to have, if you keep swirling your bottle full of dirt,
it's never going to totally stratify.
It's not always like you're not going to get just the heaviest stuff at the bottom. if you just keep shaking it up, it's gonna you're gonna have stuff mixed in there. Now, it's not to say that there's probably copious amounts of heavy metals, heavy elements in the mantle and things like that, but you're gonna get plumes of this stuff come up where you're gonna have concentrated. There are concentrations of things like iron, gold, silver, whatever, just based on not consistency, but the content of your magma.
Okay.
So you can go so when you find a lot of gold deposits, you can have an epithermal gold deposit, which you can have a magma chamber that has a lot of, say, gold, silver, copper. They're just commonly found together. And the way the deposit forms is it goes through like hydrothermal veins. So almost like boiling water, boiling fluids go through the rock. And as it cools, as it hits the cold rock, it precipitates out things like gold, your heavy metals, right? So you can get it. Sometimes you'll have it and it might not, hit that crystallization point. It might continue to develop. That's why in certain systems you'll have very fine grained crystals. Other times you'll have very large crystals. Just it's the amount of space and the amount of time that it had to cool. Longer the amount of time that it has to cool, the more the crystal face can develop. So as your magma stream goes and these weird fluids go through your rock, that's when you get you're not going to go and find just a big deposit of gold. You're not going to go find like a deposit the size of a small town that's just gold. It's all going to be speckled throughout the veining system, right?
Oh, okay.
And it's
not going to. So when you think I know you might not be thinking of it like this, but when you get your say fractures and faults in a volcanic system, the fluids that permeate through that is what's going to be carrying your heavy metals.
Okay.
So you have your low dense host rock, or your less dense host rocks, right?
Right.
And that'll have fractures, fissures, and your volcanic fluids will pulse through that after your volcanism is complete. It's almost like remnants of it. That's what's going to be concentrated in your lead, gold, silver, antimony, things like that, right?
Wow. I didn't know any of that. That's really cool.
So that's like the same thing could be said, like, why would there be lead in water? Wouldn't it just settle out? But a lot of things get suspended in the water as you go through it, right? In the fluid.
Right. Colloidal or whatever.
Yeah, it's when things are constantly in motion, they don't have a tendency to just settle out, right?
Right.
So that made me think of the mercury content in the ocean. So there's
it's like pretty high. Typically, like, you have a lot of mercury, but I don't know a lot about that actually. You get a lot of mercury in seafood, right?
Right, and as far as I understand, the mercury is like in some way.
Well, it tends to show up in bottom dwelling things because mercury does tend to settle, and you end up with pools of it in certain places. And then like the bottom dwelling creatures, like the crustaceans, walk through it and they end up with it.
Right, but of course, like old fish, like the older the fish gets,
old
the
sharks
more,
have it in it. Yeah,
because they've eaten more of the bottom feeders over
okay.
time
Yeah.
through bioaccumulation. Yeah.
history solved. All right, good point.
All right. So, what was the weirdest thing that's ever happened to you?
Yeah,
Even not in mining, just the strangest thing that's ever. What was one of your strangest experiences ever?
Ever?
Yeah, just anything like the weird, like when you think of like
geology.
Yeah, it doesn't have to be geology. Just like weird shit that happened to you. What's
Okay.
the strangest thing?
So this is going to be a bit weird.
That's the
So,
question.
This is like, it's like my probably my second or third time at a strip club when we were in university.
Okay.
And I lived with a couple of guys who like to go to the strip club every now and then. So I went with them. I look like, especially back then, I looked like a child. Like I'm almost 30 now, and I still get ID'd when I go to the liquor store. And it's only 19 to buy liquor here.
Okay.
So I look like a child still. So I was at this strip club, and there's this middle-aged woman just eyeing us. And she was wearing like it looked like a Christmas sweater, but it was September. So it was very strange. So anyways, like we're like, okay, she's obviously like something's on the go. So we're just, minding our own business.
Bothering no one.
Whatever you do at a strip club, just having a beer, watching the live entertainment.
Yeah.
And she comes over to her table and is like, "Hey, boys." And we're like, "Okay, hey." And we look up and we notice that she's actually wearing an eye patch.
Whoa.
Yeah, so she's wearing an eye patch. So she's basically a pirate at this point. And anyway, so she's there, like, she's middle-aged, hitting on a few super young dudes. Like, I looked like I was like 14. So it was getting really weird. Like, I was pretty self-aware. I knew that I looked like I was young. So it was weird when older women start to hit on you. You're like, oh, yeah. It's getting dicey. So anyway, she was relentless, like just like absolutely relentless. And anyways, we're like, no, we're not doing anything. We're good. Thanks, but no thanks. We're going to mind our own business. And anyways, she's like, starts getting a little drunker. And then she gets up on the stage as the missus was dancing. And then her and the dancers start dancing and taking off her clothes. And we're just like, oh my fucking God. Oh my fucking God. So I'm watching it. She still had her eye patch on the whole time. Yeah, you can't forget about the eye patch. So like, we're watching this pirate up there stripping with an actual stripper. And we're like, I'm not sure if this is the most uncomfortable thing or the most amazing thing we've ever seen. So we watch and they just start they like get completely on the go. Like they get, basically up on stage doing what you wouldn't want to see. Just like full on, like giving her full on, just at it. And we're like, oh, very good. Anyways, she gets hauled off the stage then and escorted out because I guess there's only so much you can do. So we look at each other and we're like, okay, that's done. We're out of here. We're fucking off. That's enough tonight.
Yeah. Just watched a pirate
yeah.
strip on stage.
Yeah, so that's my dealings with Jack Sparrow,
Wow.
Man, oh man. That was enough. That was enough for the night. That was good. That did me in.
So the craziest thing that ever happened to you in the geology world, we're just not even going to go there now. It's like,
that's not even. I was gonna say like
it was a lot slower than that,
but that's like.
I was expecting like maybe a UFO story, but no, we got a pirate stripping on stage. That's amazing. That was the best weird story I've ever heard.
It was something. It was very, very uncomfortable for like 20-year-old, 19-year-old.
Yeah, I can
go
bet.
see. It was great. It was great, but it was uncomfortable. It's times like those you reflect and go, oh yeah, that's what changed in my life. That's where something.
Yeah, that was a turning point.
Yeah, that was the turning point. Yeah.
All right, man. Well, this has been fantastic. We really appreciate you coming on the show with us. We've had a blast.
Yeah, bro. Thanks so much.
Yeah, no problem. I had a good time. It was awesome.
Yep. And we want to give another shout out to the C Word podcast. Everybody go check it out. Sheldon is usually on there talking about rocks.
I've only missed one.
So it is a great podcast. The format basically is their friend Matt researches a big conspiracy and then gets them all on, and they have no idea what he's going to talk about, and then he tries to convince them that the conspiracy is real. And it's a roundtable discussion, and it's hilarious and awesome.
Yeah, we're not. Some were easily swayed on, others not so much.
Yeah,
depends on basically how outrageous it is. But
right.
The UFO one I was disappointed on because I thought like Roswell was a big deal. that
yeah.
was like, oh man, that was disappointing.
Wow. I loved the Atlantis episode, I have to say. That was a great
Cool.
episode. So,
Awesome.
Yeah, so we want to tell everybody to go check that out. And Sheldon, thank you so much. We will hopefully talk to you soon again.
Yeah,
the
sounds good. Thanks for having me on.
We'd definitely like to get your opinion after the next catastrophe happens.
Yes. I'll actually like, I'll be in on that. I'll be like, yes. I'll be on the ground floor. Yeah. So if any major catastrophe happens, let me know.
All right, we'll do, buddy.
We'll totally let you know.
Cool.
Yeah.
We'll report it on
Sounds good.
our
Thanks,
space
guys.
weather news.
Yeah, you can
Yeah.
make your ice cave and start your next breakaway civilization up there under the ice sheet.
Will do.
All right, man. Have a good night. Thank you.
Thanks. See you later, guys.
Bye.
Later. All right. Fantastic.
That was a great episode. That was an excellent story at the end there, too.
Hell yeah.
Yeah, I definitely did not see that coming. It
Yeah.
was fantastic.
All right, we are going to do the ending. We got the ending list here. So you guys can get a hold of us at brothersoftheserpent@gmail.com.
Check out the website, brothersoftheserpent.com or .net or .uk.
Wait, no.
Oh, wait.
I don't have those yet.
Oh, you didn't buy them all?
No,
Okay.
I didn't buy them all.
All right. Yeah. We would really appreciate comments. Any comments? We like to peruse through the comments, and most likely we will read interesting ones.
Yeah, and we have actually gotten a good couple of comments on the last few episodes, which we will read on the next show.
Yeah, we won't read your comments when we have a guest.
Yeah.
So,
Yeah, sometimes we'll do emails, but the comments, we try to save those for when it's just us.
yeah. And check out the encyclopedia and the glossary of terms on the website. We use a lot of these terms through the course of the podcast, and people
Yeah.
are like, what is a butt flapper? Go check out the glossary.
That's right. And follow us on Twitter at Snake Bros, Snake Bros with no vowels, SNKBRS. We are very active on Twitter. Post there almost every day. We have lots of updates and show content and funny things.
And
So-
sharing the shows helps us a lot. So if you're on Twitter and you like a show, we post the show with the link. And if you share that with your friends, that helps us out a lot.
Absolutely.
And wherever you want to share it.
Yes. Share it. Facebook,
Just
Instagram.
Always share.
And don't forget to donate to our pyramid scheme. You can find the donate button on the website at brothersoftheserpent.com. It is on the upper right. You can see it. Donate goes through PayPal, debit card, MasterCard, any kind of credit card. Even the smallest amount helps, guys. And we
Yeah.
really appreciate all of those of you who have donated. Thank you so much.
And we are looking to get a Patreon account.
Yeah, we're going to be setting that up pretty soon.
Yeah, so all of you people who are just desperate to get a monthly subscription to free stuff that we give away, we're going to do that for you.
That's right.
We
And
appreciate that very much so.
also, very excited, we have the new Snakeskins merchandise store on the Brothers of the Serpent website, where you can go get all your Brothers of the Serpent gear. There are pillows, phone cases, shirts, hoodies, towels, pillows. I already said that once. Coffee cups, like tote bags, laptop cases. They just pretty much have everything.
That's right. Shed that low V white T-shirt that you wear every day, and get
yourself
new skin.
Get yourself a snakeskin, Brothers of the Serpent. That's right. You can find it on the website under Snakeskin Merchandise. The link up there on the upper right. And don't forget to give us reviews anywhere you go. 5-star reviews.
Yep.
Tell people you hate us, but give us 5 stars.
Yep.
And also, we want to thank History Shift, or Brandon Ricks, who has been basically running our YouTube channel for us. So you guys can now find us on YouTube. He has been taking all of our podcast audio and getting the pictures and combining them and making YouTube videos and posting them. And he is awesome. We can't thank him enough. You can find him on Twitter at History Shift. You can also find his YouTube channel. Look up History Shift, and look up us on YouTube now, Brothers of the Serpent, if you want to listen to the podcast and also see a slideshow of the photos that we were referencing during the show.
Yeah.
So thank you, Brandon, History Shift, for doing that. Thank you so much, man.
Thanks, bro.
You are a godsend.
Can't thank you enough. Thanks.
And that's it. Good night, Adamu. Get back to work.